Good morning. So this is Dr. G.Sreenivasa, Associate Professor, AAA Department, Jeepalad Engineering College, Karnal. So today I'm going to tell about something about the HVDC transmission system. See, in HVDC transmission system, why we go for the HVDC transmission system, and especially at present modern power systems, we consider the present modern power system. Definitely, at present modern system having the advanced power semiconductor device we are using. So for this reason, in a DC transmission system having the more advantages with the help of this modern power semiconductor devices, so that we go for the HVDC transmission system, especially for the contextual needs for that present scenario, especially for the long transmission system with a high voltage, especially for the submarines, undergrounds, all these things. Definitely, we require the DC transmission system. I mean, high voltage DC transmission system. And today we are going to discuss about the basic concepts of HVDC transmission, uh, different apparatus which we required for the DC transmission, and comparison of AC and DC transmission, and then various applications of a DC transmission. So coming to the overview of this session, so general, I'm going to cover about the general aspects of a DC transmission and the comparison of it with this AC, and then the converters which are using in the DC transmission system, and the analysis of especially converters, bridge converter, and the control of DC converters and the complete system, and protection of these HVDC transmission stations. Especially, the major task in the protection is for the converter stations. Before starting, we need to know about the historical structure, how the evolution of DC transmission system is, and before that, how this electrical energy is started. All these things. Okay. See, this evolution of the power and the evolution of the power system starts late in 1870 itself, and the commercial use of electricity in 1870 itself. In 1882, the first electrical power system, which includes the generator, cables, fuse, loads, all these, by Thomas Alva Edison at Farrell Street Station in New York. Okay. So, but it is a DC. Okay. So in 1882, it is a DC with a voltage of 110 volts. Underground cable is used to distribute the power. Okay. So at that time, only 59 consumers have been utilized and benefited with this 110 volts, right? That too DC system. Okay. So whereas in 1884, the motors were developed by Frank Sprague. So after the invention of motors, right, the electricity is used more effectively. Okay, the more effectiveness it comes at 1884 itself. Whereas in 1888, having some limitations, identified some limitations, so losses and the voltage drops and transmission of voltage requirement, all these things are identified. So it is become a somewhat a drawback. So, in that drawback itself, identified the transmission, distribution system with the help of transformer, developed by William Stanley. And in 1889, the first AC transmission system in USA between Willamette Falls and Portland, Oregon. It was with a single phase 4 kV over a distance of 21 kilometers. Right. So before that single phase AC supply within 4 kV through the distance of 21 kilometers, Tesla developed a polyphase system and has a patents of generator, motor, transformers, and transmission systems and transmission lines. Right. So in 1890, there will be a controversy in the industry. Especially in the electrical industry. with the standardization. So which one is the standard, whether it is an AC or DC? So okay, so addition is for DC system, whereas in the Westinghouse in the AC system. So later, the AC system is more dominated and preferred, and it is mentioned that AC system is more comfortable compared to the DC transmission system. So that the evolution has been started from 1890 to right now we have 765 kV, even in the 800 is also under construction. Okay, that this is the evolution in 1893. So up to 93 itself, it is only single phase AC supply, whereas in the 1893, it is three phase line with a 2.3 kilovolt operating within 12 kilometers in California. Okay, so from there, the improvement in voltage levels has been drastically changed year by year. As of now, it is 1100 kV under the construction, and 765 kV is at present we are utilizing satisfactorily. Okay, so year by year we can see this voltage levels improvements. In 1922 it is 165 kV, in 1923 it is 230 kV, in 35, I mean 1935 287 kV, in 1953 330 kV, in 1965 500 kV, in 1966 it is 735 kV, and 1969 it is 765 kV. Now we are utilizing 765 kV. Okay, so even in 1919 itself 1100 kV has been established, but it is in under construction, it is under a research process. But in India, we have the standard voltage levels. So based on the generating voltage levels, that is 11, 33, 66, 132 kV. And these levels are preferred, these voltage levels are preferred for high voltage transmission system. Whereas the 400, 440, 500, 765 kVs are preferred as an extra high voltage transmission system. Okay. And for the interconnection of AC system, definitely we require some standardizations, not only the fixed frequency, even for the other conditions also, phase sequence, voltage levels at both sides, all these we required. So whereas in, of course, some frequency, why we preferred that frequency means, based on the frequency only, the speeds of the missions will changes. So that the frequency is a important consideration factor. In India, we are using, not only India, in Europe and Asian countries, 50 Hz frequency is the standardized frequency, whereas in the other countries like in Canada and US, Canadian countries and US countries, uh, they are using 60 Hz frequency. So next, coming to the advantages of HVDC transmission system, definitely why we go for this DC compared to the AC transmission system. I mean, existing AC transmission system, we need to replace. Why? Having some advantages. See here, that the advantages are a less cost of transmission system. Even the investment cost is somewhat high. Once we can invest that initial cost, then the running cost is almost negligible, and having the break-even distance, so better technical performance compared to the AC transmission system. So in that, the full control over the power transmission. So we can control the power handling capability, we can control the power transfer capability, and the ability to improve the transients and dynamic stability in DC system, and fast control to limit the fault current. Why? Because we are using converters, we are using the power semiconductor devices, so that it is easy to control the other limitations, and having the more stability and voltage control, and the line compensation is also very negligible compared to the AC transmission compensation system. And interconnection problems in AC system, but here we don't have a interconnection problem. Okay, so that's why this DC transmission system, we can call it as a asynchronous interconnection system. And ground clearance and the ground impedance also very comfortable compared to the, so each and every one you can say it is in less. Okay, even in that, I mean, reliability point of view, everything. Okay, so this is about the introduction and why we go for the HVDC transmission system. The next system will continue in the